Hi, I'm Craig Smith, and this is Eye on AI. Before we begin, I want to shout out to our listeners beyond North America and ask that some of you get in touch. I'd love to know who you are and what you do. In Africa, we have listeners in Ghana, Tanzania, Uganda, and Somalia, among other countries. We have listeners in Iceland and Nepal. A handful of people tune in from Bangladesh, others from Kazakhstan. If you are listening from one of these countries or any country outside the U.S., email me at Craig, C-R-A-I-G, at ionai, that's E-Y-E hyphen O-N dot A-I. Maybe we can do an episode with listeners from around the globe. This week, I talked to the inimitable Ben Goertzel, who anyone paying attention to AI has seen at conferences or on YouTube with his long curls and cheetah print slouch hat, introducing Sophia, the AI-enabled talking head, or waving his hands as he describes the path he believes will take us to human-level artificial general intelligence, otherwise known as AGI, the holy grail of AI research. Ben is a curious character, one that I've been fascinated by since first hearing him speak in 2017. He oversees a global network of researchers working on a sometimes confusing array of disparate projects, most under the umbrella of his nonprofit foundation, SingularityNET. When I met him, he was living in a village house in a rural area of Hong Kong, and he now lives on an island off the coast of Washington state. He spoke to me about Sophia, his talking Philip K. Dick avatar, his work in medical AI, his frustration over big tech's dominance of AI research, and his own quest for AGI. Get ready. Ben talks fast and covers a lot of ground. I hope you find the conversation as beguiling as I did.
I'm very interested in the drive by many researchers into unsupervised learning, different forms of unsupervised learning. I'd like to hear generally your thoughts on unsupervised or self-supervised learning that doesn't depend on labeled data. And then personally, I'd like to hear what's going on with Sophia, because I see you on the internet all the time with Sophia, but I've talked a lot to people in NLP and the chatbot world, and I don't understand what's going on with Sophia, because I know that chatbots are not that sophisticated. Is Sophia truly connected to an AI that when you speak to it, it is speaking back?
She is. I mean, it is a topic that people are very confused about in many different directions, both thinking it's more than it is and less than it is. Sophia obviously is David Hanson's creation more so than mine, although I led the software team in Hanson Robotics for a few years. And the first thing to understand, that's a hardware platform. And It's a mushyware platform with a face. It's flexible, but you can control that same robot with a host of different software systems.
Right.
And if you're a naive observer watching a video with a robot, there's really no way to tell what's going on behind the scenes in any given instant. So when Sophia is on a major talk show or something, it may well be that's entirely scripted in advance. Of course, the humans may be entirely scripted in advance also, and reading a script or reading off a teleprompter. There could also sometimes be some AI-driven chat in there, but by and large, in such encounters, there's a lot of scripting going on. And when Sophia's standing up, like giving a speech to the UN or something, there's a lot of just someone typed in a script, and Sophia is reciting it, and that's not AI, right? It's very cool robotic. Now, we also a number of times we ran a fairly sophisticated AI system using our Opencod platform with Sophia as the input-output. And I mean, then whatever is said is going into some knowledge graph, and there's some integration of visual perception with language. And we ran that in some trials. We published a paper in one of the NIPS conferences, which was Sophia giving like meditation guidance. And that was really quite cool because people got into some profound trance states after talking to the robot. And that was running this whole neural symbolic AI platform behind Sophia. It's in some ways more sophisticated than Alexa or Google Assistant, in some ways probably less. But anyway, it's a real AI. Now, much of the time, Sophia is running the Hanson AI chatbot system, which is intermediate in subtlety between those two extremes. It's not Opencod, but it's also not just scripted. There's a rule-based chatbot in there. They have their own chatbot system called Soul Talk, which has a whole bunch of if-then rules with variables that are organized in a bunch of trees. There's also a transformer neural net in there that it falls back on sometimes, right? So a GPT-3 or BERT type thing that they train particularly. And then there's some neural models to deal with visual perception. So it's like a messy hybrid system with some rule-based chat, more like a game tree dialogue system. But sometimes it will call on a generative neural model to utter something. I know the rule-based pretty well, so I can sort of tell when it's the neural model versus the rule-based tree, but most people couldn't tell. I don't think that system is especially less sophisticated than a Google Assistant or an Alexa, actually, which is also has a bunch of rules and some neural models mixed up. And it's not trying to be as useful as those are, but it's trying to be more emotionally evocative than those are. And so then the confusions are, because there's a beautiful human face associated with it, some people are like, oh yeah, she really understood me. And on the other hand, some people are like, no, that's all puppeteered by some human or something, which is not the case either. The reality is it's another like hybrid dialogue engine, which occasionally really does understand something it's saying and often doesn't, by my subjective interpretation, understand what it's saying, but is just giving some plausible sounding. Right. That's just, the reality is boring and complicated, so no one wants to pay attention to it, and they want to either say it's a fraud or it's an AGI, which is not.
Yeah, I can see for Hanson Robotics, it's been a wonderful marketing tool. What's the why? Why is it out there? Why?
The why is a bit complicated. David Hanson is an artist, right? And so he started out wanting to just bring his sculptures to life. So in a sense, the original why was really the same why of an art installation or a sculpture. Yeah. That's really what drove David as a person to do it. And then he has a whole singularitarian ethos where he believes the singularity is going to come. He thinks AGI is going to be smarter than people. He wants them to be loving and compassionate. But as an artist, his intuition is you want the AIs and robots to empathize with people, and that's going to lead us in a beneficial direction. So that's ultimately the why is David Hanson as an artist and visionary. And then when you wrap it into a business, there's a PR goal. And obviously there's a goal of moving towards scalably manufactured like home and office service robots, which will then lead in a little bit different direction than Sophia is. So what we're doing with Hanson Robotics now, a joint venture between Hanson Robotics and Singularity Studio, which is one of my companies I'll tell you more about in a few minutes. It's a joint venture aimed at basically humanoid nursing assistant robots for elder care. So it's the same essential hardware platform as Sophia. We're going to sculpt a slightly different face for it, but the objective is different and both more and less ambitious, because this is aimed just to be like a useful robot to provide some companionship, some conversation, some advice, listening, and help with scheduling things in the house and so forth. That's an example of something you can do with the Sophia platform, which in some ways is easier and some harder than making a general purpose chatbot, right? Because on the one hand, it doesn't have to hold forth about sports or politics or anything. On the other hand, it actually needs to understand what's going on with that patient in a sense. So that's the one I'm involved in because it interested me more, because I've done a lot with biomedical AI. They can roll out like car salesperson robots and so forth. You can view Sophia as a showcase, and then it's a platform that can be used to make domain-specific products. So in terms of pure research, I found it very frustrating because Sophia has to pretend she knows what she's talking about when she doesn't. And if you're trying to do AGI research, you want the system to be talking only about what it actually understands. You can teach it. You don't want to, like a bullshit artist, right?
Yeah. And for real AGI research, the platform is irrelevant, right?
No, I don't know that the platform is irrelevant. There's an argument that having a robot that can interact with other humans in a shared physical environment is really useful for teaching an early stage AGI. Actually, I think the platform is great. You need to do something different with it, right? Like, you want the AI to be learning about why this is a cup rather than a bowl, and like how much stuff will come out of it if I spill it over. So you want the dialogue to be grounded in the robot's experience rather than using the robot as a mouthpiece to whatever random thing people want to talk to the robot about. So the use of robotic hardware and humanoid robotic hardware for AGI research is arguable, but it's certainly not trivial or dismissible. It's interesting. But the use of a robot character that has to give the illusion of having an understanding it doesn't have for AGI research. I mean, that's more complicated and in some ways is a negative use, right?
Yeah, actually, that's what I'm getting at, because a lot of people know that I'm interested in machine learning, and they're like, oh my God, have you seen the Sophia? And it creates, in my mind, a lot more confusion than understanding.
Yeah, although there's a lot of machine learning on the back end there, of course. There's computer vision for face recognition, there's reinforcement learning for movement, there's transformer neural nets, but on the whole, they're combined together in a particular way. But again, that's true in Google Assistant too. And that also confuses some people in a different way, actually. It confuses my 2-year-old son.
We'll get off this topic, but also the Philip K. Dick video.
That was like 90% transformer neural networks. That was Opencod plus transformers. So we made a very simple Philip K. Dick chatbot in Opencod, just to sort of wrap conversational pragmatic. Then almost everything that PKD said was from a transformer neural net we trained on Philip K. Dick's exegesis and his letters in various novels. So that was fun. The voice was trained from Philip K. Dick's speeches also. So it was a separate like audio transformer and seek-to-seek model. That was really an art object, right? David Hansen and I both loved Philip K. Dick. And I just thought the weakness of modern transformers is they generate a lot of bullshit. So I thought if you're generating something that's supposed to be like a stoned philosopher just saying weird, cool stuff, then that becomes a feature as much as a bug. And it's cool. And it did work out that way. Like that rambles all sorts of wacky out there stuff, much like Philip K. Dick in some of his diaries and writings. In the medical, actually, we're battling against transformers in a different way. We had one interesting experiment I did a few months ago. I just set up a huge online dialogue between Sophia's chatbot and the transformer dialogue model, similar to Facebook's chatbot with some improvements, but just have the two chatbots chat back and forth each other. The neural model, on the whole, seems a little more fluent in the diversity of syntax it throws at you. And it's much worse at keeping the thread than Sophia's chatbot with the rule-based aspect, like digress more. And of course, the transformer models have the feature that like 10 to 20% of what they say is complete utter bullshit that makes no sense, but looks like it does. In this elder care robot use case, it's very bad, right? Because you can't have your elder care robot say even 1% complete random bullshit. So that means either you need to use a rule-based system instead for dialogue. We have some rules in there because there's some content which is just, it has to be a certain thing due to the nature of the domain, like their diagnostic questions or their procedures of a hospital or something. But we don't want to get into encoding a huge amount of rules for a medical assistant. On the other hand, we also can't have it bloviating random things, some of which could be inappropriate or dangerous even, right? You need a way to use understanding of the world or structured knowledge to guide what the generative model is doing. And so that's one of the things we're working on in the context of this project. It's called Awakening Health, this elder care robot project. And there's two approaches there, right? One is you give a bunch of negative examples and you try to train the transformer model to avoid anything like that in the certain stage. The other, which is more interesting, you can take a tree transformer type approach and you give a knowledge graph and then you use a knowledge graph to bias the generation of the generative model. Like in a tree transformer, they have a simple constituent grammar biasing generation. but we can have a whole Opencod knowledge graph biasing generated. Like that applied project, it's not AGI, it does force us to do neural symbolic stuff and to push beyond the neural models. But see, to do that with Philip K. Dick is too hard. What's in that knowledge graph? Like the universe and everything. Whereas with the medical robot, what's in the knowledge graph? There's actual structured ground truth data about drugs and diseases and schedules and so forth, which you could use to keep the generation on track.
Fei Li is doing a lot of research on ambient AI with multiple sensors, and you could combine that with other kinds of sensors and have the robot ask questions when it senses that something's going wrong.
In some of my more like corporate consulting stuff, my team built like face re-ID systems for big box retail. We'd recognize it's the same guy walking out of the scope of this camera into the scope of that camera. So that same software you could use for the cameras in the hospital. It can feed into an AI that the robot's mind is.
That'll be fascinating. I have to tell you a little anecdote. My mother, who's since passed away, was in the hospital a few years ago, and the hospital rolled in this very crude looking robot. It had two camera eyes, a little speaker mouth, and it would sense movement, and then the nurse, rather than having to run down the hall, would get on a microphone and say, "Are you okay?" Not my mother, but the person next door. The robot spoke up, and the woman lying in bed said, "Is that God?" Which I thought was interesting, the understanding of what exactly is happening for an elderly patient.
We've been doing some investigation with elder care facilities and working with a company in the U.S. called Connected Living, which has IT infrastructure rolled out in hundreds of elder care facilities. There's a lot of people there who know all the options on their iPhone better than you or me. Right? They're not doing much else all day, and they're quite sophisticated. And then there's another segment of patients who forgot their kid's name. Making a robot to deal with both of those cases is a very interesting challenge, actually.
Can you just, for listeners, describe Opencod?
Yeah, sure. So Opencod is a AGI-oriented software platform, which was founded in 2008, but actually some of the code existed, just hadn't been opened up yet in 2001 or something. And the notion is that AGI can be approached via cognitive synergy, via synergetic interaction of a number of different AI algorithms on a common dynamic knowledge store, where the knowledge store is this weighted labeled hypergraph called the atom space, and then the different AI algorithms cooperating together on this atom space. They have to be carefully designed so they don't step on each other's toes, but work cooperatively, and when one of them gets stuck, the other ones help them out. And this transcends distinctions like neural versus symbolic, because this knowledge hypergraph has some symbolic links that are morphic to, let's say, predicate or term logic constructions. It also has neural net links. So you can do neural and symbolic together in the same distributed knowledge hypergraph. We've been playing with this sort of thing since the late 90s. We've made a lot of progress in a lot of different application areas. And I'm really curious to see what happens when you massively scale this up, which is what pursuing the True AGI project. SingularityNET helps with the infrastructure for scaling that up, but there's a whole bunch of other interesting things that we need to pursue. It's a very different direction than what the mainstream of the AI field is taking now, which is mostly focused on like back propagation through huge like multi-modular neural networks. So we can connect neural nets learning through backprop with the Opencog atom space. Say if you're doing probabilistic programming, you can have the same probabilistic program act over part of the atom space and some deep neural nets. But it is a different way of representing and organizing knowledge.
That's fascinating. Okay, let's talk about where you're spending most of your time.
Let me give you the big picture. So I've been leading as CEO of this project called SingularityNET since 2018. It was founded in 2017. That's a blockchain-based AI infrastructure company, right? So we released a platform that basically lets you make a decentralized society of minds with an economic aspect where there's a token to pay AIs in the network for services, although you now pay in regular money. And it's converted to the token on the back end. And then the AIs can outsource work to each other on the back end. So that platform exists. And then from a business view, the big challenge is getting traction for that platform. Like, why is anyone going to use it? And there you have the same problem of any other platform in the tech business, like an Airbnb or an Uber or something. Like, more AIs in there, the more people want to use the AIs, more users, the more AIs will go in there. So what I've been working on is actually SingularityNET as an entity is spinning off a bunch of other companies, mostly for-profit companies, and partly because we've been incubating these things internally inside SingularityNet, and they just need more resources, not just money, but more collaborators to grow. And partly that's one way to get traction on the platform is like to venture studio type approach, like spin off companies that will then use the platform, and then hopefully that will kickstart the growth of it. So these are all, of course, AI related in various ways. And so I described one of these spin-offs, which is Awakening Health, which is doing these nursing assistant robots. That's a joint venture with Hanson Robotics. So I hadn't been doing that much with Sophia or Hanson Robotics for a couple of years, actually, although we did this Philip K. Dick thing just for good fun. But now we're plunging back into Sophia land with a bunch of new AI technology. Another of these spin-offs is called Singularity Studio, and this is basically, it's like an Element AI or Palantir type thing. Palantir, but focused on doing good. It's an enterprise AI, and we've been looking a lot at the healthcare space there. So we're working with some folks doing COVID clinical trials. They're doing trials of like cocktails of multiple antivirals, and then we use machine learning to figure out which antivirals to give someone based on gene expression data. And we've been looking at some breast cancer stuff in the same context. Basically, using neural symbolic methods or fancy neural methods like InfoGAN, but also some probabilistic reasoning to try to do transfer learning better from one clinical trial to another. Because the current state of things, when you do ML on a clinical trial, it's very hard to get the models to transfer even to another trial of the same drug on a slightly different patient population, let alone to do transfer to a different drug or something. So we're trying to get transfer learning to work for personalized medicine trial analytics, and with interesting success, actually. Like, this is the first thing I've gotten InfoGAN to work in a useful way, which is that's a kind of generative associative network with unsupervised learning. Like an InfoGAN automatically learns structured latent variables as part of the generative model that tell you semantic features of the data it's modeling. So like an InfoGAN for face recognition, it'll automatically learn one variable for how wide the eyes are, one variable for how long the nose is, one variable for how fat the lips are or something. So it's learning that unsupervised, like what are the key features of the things that it's generating. So that seemed really cool when it came out, but I never found anything was actually more useful than simpler models for until clinical trial analytics. It actually seems to be. And I think the reason is there you have very few samples relative to the complexity of the data. Like in face recognition, it's cool to see that the system by unsupervised learning will recognize the key semantic features of the face, but it doesn't matter because you have too many faces relative to the complexity of the face. For a clinical trial, you have a couple thousand patients, but the genome of each patient is large and there's so much diversity among people. So yeah, what we're looking at there is using these InfoGAN type models to extract key features from patients as related to the therapies they're taking. And then we use sort of logic reasoning to try to come up with a causal explanation. Like, why are these semantic features there? Why are they important for predicting if someone's going to be cured better by this drug than that drug for their breast cancer or their COVID? So that's not AGI either, but it's being very interesting. And we're seeing a big value for neural symbolic combination there, which is interesting. I think biology is good for that because the data is scant. And so you can't do like you do with face recognition or GPT-3 or something because we don't have gene expression data from every human on the planet in our data at this moment. Hopefully we will eventually.
Yeah. And where's this research being done?
This is being done with SingularityNET Foundation, but then Singularity Studio is spun off as a for-profit company. We're working with hospitals and pharma companies and such, just doing data analytics on a commercial basis. Physically, we're all over the place. Our biggest AI team is in St. Petersburg, Russia, but we're in Belo Horizonte, Brazil, in Ethiopia, in Addis Ababa, and in Bangalore, in India, and then Hong Kong. few of us scattered around the U.S., but we don't have a central presence.
And so this research, is there a central platform that you're all working on, or is it just emailing and working through Slack? I'm just curious.
And how does the coordination work in
Yeah.
GitHub and Slack? Same as everybody else, really. In terms of the software, there's SingularityNET platform, and there's Opencod engine, and then a whole bunch of neural nets of various sorts. We have a server farm in St. Petersburg, which we've customized heavily to be relatively efficient for the kinds of AI that we want, because using AWS and stuff for this is very expensive.
Right. So it's kind of a private cloud.
Yeah. For Transformer, that's highly demanding on like multi-GPUs, but then Opencog is highly demanding on because you're giving these big graphs in RAM. I mean, of course, AWS or Azure can do anything, but the cost per hour becomes very high. But yeah, there's other things. We're launching an app on the App Store, which is also medical focused, which is it's a Rejuve app, and that's from a different spin-off project called Rejuve. It does biosignal analysis on data from your Apple Watch, like pulse oximetry, HRV, and also temperature from digital thermometer. And so we do anomaly detection to detect infection before you feel sick, if there's something screwy in your body. And so that's, again, pretty interesting and not on my main AGI research direction, but it's clearly quite valuable. And that's, the more data you can collect there, the more interesting stuff you can discover, right? Because now there's no Bloomberg of health data, right? There's no huge repository of data you can use to drive forward machine learning or machine reasoning in these contexts. So yeah, SingularityNET is going into other stuff. We're launching a big decentralized finance project soon, which is a whole other topic, which is machine learning for automating like crypto utility token market making and arbitrage and so forth. So there's a lot of interesting ML applications in the crypto finance space, actually.
Yeah.
You can do some things. There's already all sorts of AI in traditional finance. The crypto domain, you can do some things you couldn't do in traditional finance because of peculiar characteristics there. And that's fun. If you play with quantitative finance, it's like a whole new playground. But then the other thing I'm doing, which I wanted to save a little bit of time for, which is what I'm spending probably half of my own time on now, which is the biggest chunk I'm spending on anything. So we have one more spin-off entity from SingularityNet, sort of an ensemble, which is called True AGI. And this is, as the name would indicate, my attempt to move back further toward my roots, and using the SingularityNet platform and the Opencod system and so forth, make a full-on push to actually get human-level general intelligence. This is based on what we're calling Opencog Hyperon, which is a new version of the Opencog AGI engine, and then building some specific learning systems while we build out Opencog Hyperon system. And SingularityNet is then part of the plumbing, like part of the platform for it, which lets you distribute pieces in a decentralized way nicely.
And in that research, how do you divide your time?
Pretty haphazardly. In daily practice, in the morning I'm being a CEO and doing a seemingly endless series of meetings. In the afternoon, I'm being a dad and romping with my 2-year-old on the beach and stuff. And then in the evenings, which can run quite late, I'm doing AGI R&D stuff. Leads to a dramatic sleep reduction scenario, but I get a lot of cool stuff done.
On the AGI research, it's not simply a matter of stitching things together. There has to be some basic breakthroughs in unsupervised or supervised.
I think that the recent hype about unsupervised and self-supervised is pretty funny, because some of us have been doing that for many decades, and the folks were doing that even before I was born. But now somehow people from a big company do this, and it becomes exciting and new. Just like Yoshua Bengio, who's a great guy, and he published a paper on the consciousness prior. The human body and the three-dimensional structure of space should be considered as prior distributions to inform probabilistic learning. And I had a paper called the embodied communication prior, like 2008 or 9 or something, which said the exact same thing, but with a lot more detail, but nobody paid attention. But now a deep learning guru says the same thing very nicely, but with less detail into it. And suddenly that's a revolution. And it's the same with unsupervised learning. A lot of us never thought supervised learning had much to do with AGI, and that now suddenly a whole group of people lead you down a completely useless direction for AGI, although useful for many applications. then they're like, oh, actually, maybe we should do this other thing. And then they get credit for proposing what their opponents were proposing for 50 years. So of course, labeled training data was never the way to go for AGI any more than expert production rules like they were using in the 70s were the way to go for AGI. And nor is unsupervised learning, as the mainstream is doing, really the way to AGI either. So I guess next year someone will rediscover active learning, like they'll rediscover that integrating action and perception is actually useful. Then they'll rediscover like social learning, as psychologists have known for a while. And then they'll get finally to embodied interactive learning, which is shared with the AI and other intelligent agents in a shared environment, and developmental learning. And then they will have rediscovered what many of us were publishing in the 1990s and 80s. So yeah, of course, going from labeled data to unsupervised pattern mining is a step forward, but it's not a big enough step forward. And I think the core problem is that everyone working for a big tech company is implicitly, if not consciously, they're driven to work on things that will best leverage the unique economic resources of that big tech company. So if you work for a big tech company, you are pushed to do things that exploit huge amounts of data and use processing power above all else, because that's the unique competitive advantage that the tech company has. And this, I don't think this is explicit on the point of view of most AI researchers. It's rather that the IT tool set that you have at your disposal, the APIs that you have, are ones that differentially utilize these server farms and these data sets. And it's so much easier to script something that wraps up your proprietary APIs than to bother to do something else. Because I tried a number of times to collaborate with some of my many close friends inside Google, and there's some bureaucratic obstacles to collaborating with outside open source AI projects, but those can be overcome. But the main thing is, if you're in Google, it's just so easy to do things involving Google's internal proprietary API, and then so annoying to have to cooperate with people who can't use that API and who are writing code that doesn't use that API. So that totally makes sense. But what it means is that when they talk about unsupervised learning, what they mean is mining patterns from the whole web or all of YouTube or Facebook's videos. Like that, they're looking at massive scale pattern mining to leverage the data that they uniquely have. And that can be very interesting for many practical applications, right? So I don't discount it as a commercial thing at all. Like video analytics is barely touched, right? And because it takes so much compute time, but as compute gets cheaper and algorithms get better, there's going to be so much positive stuff and scary stuff that's going to be done with unsupervised machine learning on video and audio. But whether that is the path to AGI, I think that's the next multi-year AGI dead end that big companies will undertake. But the thing is, unsupervised and self-supervised learning clearly are part of the key. It's just the way you do that, if you're trying to most rapidly get to the best possible unsupervised learning result on all of YouTube archive or something, is different than the way unsupervised and self-supervised learning are used in like a young child's mind or something. So that's
right, because that data is already digitized, so it's convenient.
And you don't need active learning, right? So there's a saying from Heinz von Forster, a systems theorist: if you want to see, learn how to act, right? Because when a human or an animal is perceiving, the premotor cortex is heavily involved in lower level vision for a reason, right? When a human is perceiving, they're often manipulating the environment to also. This is why a lot of the time a kid who's immobile because of some medical reason, even if they can see, they'll wind up autistic in some way. The perception-action combination, the synergy isn't there. So what we're looking at with unsupervised learning now is it's like a massive unsupervised perceptual cortex. And then you can try to integrate reinforcement learning with it in some way, but reinforcement learning is its own perversion, which bears loose resemblance to this sort of more diversely motivated learning that a young child or that any of us does. So about whether we need a big breakthrough or not, that I think remains to be seen. Like what we've done with the Opencod is we've been taking deep neural nets and an evolutionary learning algorithm, and which is evolutionary program learning with some probabilistic learning aspect, and then a logic engine. we're making them work together on this knowledge graph in a sort of Blackboard type architecture. And we're using that underlying this clinical trial stuff. We've used it in simple ways behind Sophia. We're using it in some experiments in the Minecraft world. And we're just hitting scalability issues with the infrastructure, basically. So unfortunately, we need to take a year to 2 years to rebuild that whole infrastructure of Opencod in a massively more scalable way. And so we're making a massive distributed version of our knowledge hypergraph. We're making a new gradually typed functional programming language to comprise the semantics of the nodes and links in the atom space, and then basically re-implement all of our neurological and evolutionary algorithms in this more scalable infrastructure. So if we are correct, this can have the same impact that GPUs did for deep neural nets, because of course, there are many new ideas in the neural net literature, but the crux of it is about the same as in the 1960s. And the multi-layer perceptron was a deep neural net. It just worked well enough back then. So in the same way, if we're right about this sort of Opencod paradigm with this hybrid approach to AGI, if we're correct there, then getting a scaled up infrastructure will let things start succeeding more dramatically and progressing more rapidly, just as the advance of the NVIDIA matrix libraries for GPUs did for deep learning. That's not to say there won't be a hell of a lot of things that have to be invented along the way, but you wouldn't say since GPUs became cheap and prevalent, there hasn't actually been a huge mathematical or conceptual breakthrough in the neural net space. There's been a lot of really good breakthroughs. And so it might be that after we have a scaled up infrastructure for Opencog, then we get to AGI with a whole bunch of very good breakthroughs rather than a paradigmatic shift. At least that's our working hypothesis, but we're a few years from validating that, but still that's exciting that it's not a few decades away. I mean, of course, as with any of these startup projects, a lot depends on how fast we ramp up funding into the project, right? Because this is not Google DeepMind. This is True AGI is a startup spin-off of a decentralized blockchain-based nonprofit, which is itself a startup. But assuming the resourcing works out, we've got a year or possibly a little more of just rebuilding the guts of Opencog to make Opencog hyper. We'll be doing some other AI R&D, AGI R&D in parallel with that. And then we start with a more interesting phase where we're doing a combination of building and teaching. And so we're looking at multiple agents cooperating to build stuff in a Minecraft-like world. And then we're looking at Sophia-type robots controlled with the True AGI system, but based more on embodied interactive learning, where they're grounding everything that they talk about in things that they can directly experience. And then I would say if the paradigm is right, we're 3 to 5 years from a huge breakthrough in AGI. Of course, if it happened in 2 years, I'd be even happier. If it happened in 7 years, I'm not going to shoot myself in frustration. But my friend Ray Kurzweil has projected 2029 for the breakthrough to human-level AI just based on generic curve-fitting type arguments. And my timeline is not extraordinarily far off from that. If it's 5 years, we're beating Ray by a few years.
But on funding, are you talking about VC funding? Are you talking about National Science Foundation funding? How do you come up with the funding?
There's a wide assemblage of funding mechanisms out there, right? So True AGI is a for-profit company which can take traditional investment money. SingularityNET it did an ICO in 2017. And the Singularity DAO, which is our decentralized finance spinoff, is creating whole new mechanisms of directing funding into interesting technology projects. So yeah, we're open to any and all methods of getting resources into projects that don't have the impact of handing over control to entities that we don't want to have control, right? Like, I'm not incredibly interested in creating a startup and then immediately selling it to a big tech company. I think the whole decentralized AI methodology underlying SingularityNET, part of the idea there was we're going to be better off if AGI comes about, A, open source, but B, with actually decentralized contribution and control. And by building True AGI on SingularityNET platform, I mean, you're at least increasing the odds of that happening. But That goes into AI ethics and a whole other dimension of the topic that we haven't gotten into, right? Because there's ethical risks with the vast, unwashed mass of humanity collaborating in a decentralized way. There's also ethical risks with a self-appointed elite group keeping proprietary secret control, and balancing those risks at the moment is more of an art than a science. I'm somewhat instinctively and on a human basis, like going for the open and decentralized approach, but you can't be certain about something like that in a scientific way. It's an unprecedented situation.
That's it for this week's podcast. I want to thank Ben for his time. If you want to read a transcript of this episode, visit Ion AI. That's EYE-ON.AI. I find that reading transcripts reveal much that the ear misses. You should also check out SingularityNET at singularity.net or .io. Ben thinks the singularity is near. I do not. But regardless, AI is about to change your world, so pay attention.